Welcome to Roadwork Ahead's presentation over autonomous vehicles for transportation engineering. We chose autonomous vehicles as they are one of the newest inventions in the automotive industry and are on the leading edge of new technology. Autonomous vehicles are vehicles that operate and drive automatically with no user intervention. Autonomous vehicles have the possibility to revolutionize not only the transportation industry, but the shipping industry as well, with many possible uses in commercial transportation.
Level 0 is the most common style of cars seen on the road today with no automation. Level 1 has only one built-in automation feature, such as cruise control. More common cars today fall under Level 2, with the majority having sensors on the outside of the car to allow for line spacing or proximity detection. Some cars also are outfitted with speed regulators for more rural road usage. The driver must be ready to take the wheel at a moment's notice and stay vigilant while driving. These cars drive themselves and are outfitted with a large amount of advanced technology, such as sensors surrounding the car. Weather conditions greatly impact these cars still, and once again the driver must be ready to take the wheel at a moment's notice. Level 4 is very similar to Level 3, the main difference being that they have more legal and design specifications that must be achieved in order to qualify for this level. Most cars that do are made for residential driving and lower speeds. No cars at the moment have achieved the level of 5. However, many design companies and cities are considering this idea for the future. These cars have no seat for a driver, and as a result, many ride-sharing opportunities are being discussed by companies in large cities to possibly implement later.
The automation operates through a complex system of processors, cameras, and even sonar detectors that allow the car to see the roadway and surrounding traffic. The computer then processes this data and provides commands to the controls of the vehicle in order to continue on the roadway and avoid obstacles.
Autonomous vehicles potentially have a myriad of benefits, both for the user and society. First of all, by driving, accelerating, and braking all at a pace calculated by the onboard computer, a car can operate at levels of efficiency that no human driver could ever hope to achieve. Widespread implementation of this technology could slash carbon emissions and improve air quality in urban areas. Next, autonomous vehicles could save commuters incalculable amounts of time by eliminating traffic jams and saving time at intersections. Not only would this benefit the user, but time lost to traffic is worth billions of dollars annually. Finally, and most importantly, autonomous vehicles have the potential to be far more safe than conventional automobiles. It is estimated that 90% of all crashes could be avoided with autonomous capabilities. Just imagine how safe roadways would be when things like DUI, distracted driving, and drowsy drivers are a thing of the past.
When using autonomous vehicles, there are situations that require ethical considerations. The right image of this slide shows a situation with two scenarios. The first scenario shows the car avoiding the concrete barrier, but striking 3 pedestrians. The second scenario shows the car avoiding 3 pedestrians, but striking the concrete barrier. Programmers will soon face a dilemma where a car will have to decide whether the driver or the pedestrian's lives are more important. This will lead to complicated legal situations unless proper laws and regulations are established. Moving on to legislation, there are currently 12 states without legislation for autonomous vehicles. The current legislation that does exist often varies significantly. For example, Nevada legislation contained just 23 lines of broad definitions and guidance to its DMV. California's legislation, on the other hand, includes a 6-page detailed report. This report includes topics such as testing and registration requirements, insurance bonding, and the ability to engage manual driving. Without consistency in the certification process and a standardized set of rules, manufacturers will be faced with a number of problems and a great deal of uncertainty.
In conclusion, autonomous vehicles have the possibility to solve many of transportation engineering's most pressing problems, but also present many significant challenges for tomorrow's engineers to overcome.